Let's say I want to take derivative of a multi-variable function like what we have down here. It turns out that I can take derivative with respect to each of the variable that I have, and they are called partial derivatives. The notation that we have is going to be a little different from what we used to have for derivative. Like in a single variable, let's say if my function is x squared, then the derivative of this is going to be just f prime of x, or I can write that as df by dx, and that's going to be just 2x. However, if I have a function with more than one variable like x and y here, then it would not make sense to just write f prime because it would not be clear whether I take derivative with respect to x or with respect to y. So to deal with that, if I want to take derivative with respect to x, then I'm just going to write delta f by delta x here. So this is kind of like one of the notation that we have from earlier, and I'm going to use the Greek letter delta instead of d to mean that this is a function with several variables and I take derivative with respect to x. Or I can also just write f and then x as a subscript. And the same thing with respect to y, I can just write delta f by delta y, or I can just write f with y in the subscript. Now then, when I take partial derivative of f with respect to x, so I'm going to have delta f by delta x, or it's going to be f sub x. What's going to happen here is, I'm going to treat x as a variable. I'm going to treat x as a variable. And then I'm going to treat y just as a number. On the other hand, if I want to take partial derivative with respect to y, then I'm going to do the opposite. I'm going to treat y as a variable and I'm going to treat x as a number. So I'm going to think of x as just a number and then my y is going to be a variable. I treat y as a variable. So for this example, let me actually go ahead and rewrite my function here. My function is 2x to the 4th y cubed plus sine x and minus 5y. Now, if I want to take derivative with respect to x, so I'm going to see all the x here as a variable. So the x that I see are going to be variables and then all the y that I see is just a number. So then what that means is, if I want to take the derivative of the first term, 2x to the 4th times y cubed, 2 is a number, so it stays there. The derivative of x to the 4th is going to become 4x cubed. And then the derivative of y cubed, well, because I think of y as a number, so this is just a number and it got multiplied to something, so y cubed just stays that way. Now for the next term, the derivative of sine of x is just going to be cosine of x. And now for the last term, negative 5y, notice that this term doesn't have an x in it, so this 5y I can think of it as just a number, and when you take derivative of a number, then that thing will just be 0. Notice that the first y cubed that I see stay there because this is a number that got multiplied to something. But this 5y, this is just a number by itself, so its derivative becomes 0. For example, if I have a function, say if my f of x is 5x squared plus 3, then the derivative of this guy is going to be 5 times 2x plus 0. Notice that whenever I have a number and it got multiplied to something, that number stays there. But if that number is by itself, then it becomes 0. So this is the partial derivative of my function with respect to x. Let's do the same thing with respect to y. So let me actually just go ahead and copy the function that I have. It's going to be 2x to the 4th y cubed plus sine of x and then minus 5y. Now, if I want to take derivative with respect to y, so once again, I'm going to think of y as a variable. So all the y that I see is going to be variable and all the x that I see is going to be just a number. So the first term, the derivative of 2x to the 4th, well, this is just a number, so it stays that way. I'm going to have 2x to the 4th and then the derivative of y cubed will just be 3 times y squared. Now for the second term, sine of x, this is just a number because I think of x as a number, so this is a number by itself and its derivative is going to be just 0. And for the last term, the derivative of minus 5y is going to be just minus 5. Or you can say that the derivative of y is 1, so I'm just going to have negative 5 times 1, so that's just minus 5 anyway. And for the last part, I would like to find delta f by delta y and this vertical line. This is a mathematical notation for when or at. So what that means is I would like to find delta f by delta y at the point 1, 2. So what that means is I would like to find the value of this partial derivative when x is 1 and y is 2. Let me actually change this color to orange. What I can do is I can just go ahead and plug this into what I have found earlier. So this is going to be just 2 times 1 to the 4th times 3 times 2 squared plus 0 minus 5. So let's see, I'm gonna have 24 minus 5, so I'm gonna have 19 here.